Let's talk about some common terminology to classify differential equations. In this class, you'll learn about several methods to solve differential equations, but some types of differential equations need different methods than other differential equations. So with this terminology, we'll be able to classify some of these differential equations. If an equation involves the derivative of one variable with respect to another variable, then the former is called a dependent variable and the latter an independent variable. So if we think of a derivative dy dx, then the top part is the y is called the dependent variable, and the bottom variable is called the independent variable. So let's do an example. We have the second derivative of x with respect to t plus a times the derivative of x with respect to t plus k times x equals 0. Now the dependent variables are that's the variable that's on top, so in this case that's x, and the independent variable is t. Now, this also works for when we have so-called partial differential equations. This funny-looking d is the notation we use for a partial differential equation. So the variable that's on top, that's the u, so that's the dependent variable. And then the independent variable, in this case, we have two. We have the derivative of u with respect to x, and we have the partial derivative of u with respect to y. So the independent variables are x and y. Now, a differential equation involving only ordinary derivatives with respect to a single independent variable is called an ordinary differential equation, or an ODE. A differential equation involving partial derivatives with respect to more than one independent variable is called a partial differential equation, or a PDE. Now in the previous examples, right, in example 3, we don't see any partial derivatives. So example 3 is an example of an ODE. In example 4, we have some partial derivatives. So that's an example of a PDE. Now in this class, we'll only deal with ordinary differential equations. Partial differential equations, that's a whole class on its own. Now then, the order of a differential equation is the order of the highest order derivative present in the equation. So let's scroll back to example 3. What is the highest order derivative? Well, there's a second derivative there. So the order of that equation is 2. Then for example 4, we have only the first derivative of u in both cases, so the order there is 1. And then finally, a linear differential equation is one in which the dependent variable and its derivatives appear in additive combinations of their first powers. If a differential equation is not linear, we call it nonlinear. And the general form of a linear differential equation is some kind of function times the independent, or of the independent variable, times the derivative of the dependent variable, in this case the nth derivative. Then it's a function of the independent variable times a derivative of the dependent variable, so on until we get to the first derivative of the dependent variable plus a function of x times the dependent variable, and then the right hand side can be a function of the independent variable. So this looks very complicated, but basically what we see here is that we need to have first power of any derivative. So we can see that the nth derivative is to the first power. The n minus first derivative is to the first power. And then we see that the derivative is to the first power. And then finally, we see that the function itself is to the first power, and it's all being added together. So that's the additive combination. So if we look at this first example of a differential equation, we look at the derivative of y, the second derivative of y to the first power, but then we see y to the power 3. That's not to the first power, right? The dependent variable can only show up to the first power, so this is nonlinear. And just as a bonus, so y is the dependent variable and x is the independent variable. So we're really only worried about what's happening to the dependent variable, right? There's a lot of stuff that needs to be true for the dependent variable, but not for the independent variable. So before we do this next problem, maybe it's a good idea to figure out what is the dependent variable and what's the independent variable. So x shows up on top, so that's the dependent variable, and then t is the independent variable. Now, let's redo that. So we see that the derivative of x shows up to the first power and x itself shows up to the first power. Now we have a t cubed here and a t cubed there, but t is the independent variable. So that's perfectly fine. That is basically the function of the independent variable here. That could be any kind of function. So this is an example of a linear differential equation.